In this section, we're going to examine something that represents a fundamental shift in the cybersecurity threat landscape, something that happened in September 2025 that changed how we need to think about both offensive and defensive security operations. And just in case, let me apologize because my voice is a little scratchy and I've been trying to get over a flu for a while, but hopefully it's not too annoying and I'll try to make the audio as clean as possible for you. So now before we dive into that specific incident, we want to establish a foundation because we haven't gotten into agentic AI in the course before this. So I want to make sure you understand what that actually means because this term is going to be critical to everything discussed in this section. So we'll start with the question, what is the difference between asking ChatGPT to write you a Python script versus what we're talking about when we say agentic AI? When most people interact with AI systems like ChatGPT, Claude, or other large language models, LLMs, they're using what we might call advisory AI or assistant AI. There's a number of different terms for this. You'll ask a question, the AI gives you an answer. You request some code, it writes the code for you. But then you have to take that output and do something with it. So your human intervention there. You copy the code, paste it into your development environment, run it, debug it, iterate, etc. The AI isn't doing any of that. It's just responding to your prompts. And we know that now the add-ons let us do even more and it's integrating, etc. But agentic AI is fundamentally different. The word agentic comes from agent, big surprise, meaning an entity that can act autonomously on your behalf. An agentic AI system doesn't just answer questions or generate content. It can execute tasks, make decisions, chain together multiple operations, and continue working with minimal human intervention. So we want to look at a concrete comparison. If I ask traditional ChatGPT, can you check if port 443 is open on this server? It might tell me how to use Nmap or Netcat to check. It might even write me the exact command, but I still need to open my terminal, paste that command, run it, interpret the results, and decide what to do next, or ask for advice on what to do next, whatever. An agentic AI system with the right permissions and tool access could actually execute that Nmap scan, interpret the results, decide what additional reconnaissance to perform based on what it found, execute those follow-up scans, and compile a comprehensive report, all while I'm doing something else completely, meaning no hands-on by human. It operates in a loop: observe, decide, act, observe the results, decide on the next action, and on you go. So this is what we mean by agency, the ability to act autonomously toward a goal. So we've got Anthropic. In their report on the incident that we're going to be examining in detail in the next lesson, they identified 3 key capabilities that make modern agentic AI systems particularly powerful, and from a security perspective, particularly concerning. They described it this way in their November 2025 report. So this is quoted. The attack relied on several features of AI models that did not exist or were in much more nascent form just a year ago. Intelligence. Models' general levels of capability have increased to the point that they can follow complex instructions and understand context in ways that make very sophisticated tasks possible. Agency. Models can act as agents. That is, they can run in loops where they take autonomous actions, chain together tasks, and make decisions with only minimal occasional human input. Tools. Models have access to a wide array of software tools. So that's the Anthropic quote. So we've got 3 pillars in this. Let's break these pillars down. I think it's 3, hopefully. Right? So the first one, intelligence. First, we're not talking about artificial general intelligence or even anything approaching human-level reasoning across all domains. I know it depends on the human, right? But what we're talking about is the ability to understand complex, nuanced instructions and apply domain-specific knowledge effectively. Modern large language models, LLMs, have been trained on massive data sets that include technical documentation, code repositories, security research papers, penetration testing guides, and a lot more. This means that they can understand cybersecurity concepts at a genuinely sophisticated level. So as an example, if you tell an AI system, an advanced AI system, I need you to identify potential SQL injection vulnerabilities in this web application, it doesn't just pattern match for obvious signs. It can reason about different SQL injection techniques: union-based, Boolean-based blind, time-based blind, error-based. It can craft payloads that test for these specific vulnerability types. It can interpret the application's responses to determine whether a vulnerability exists and what type it is. So this level of intelligence is what enables the AI to be useful for complex tasks, but it's also what makes it dangerous when it's misused. And anything powerful is what? Dangerous when it's misused, of course. So let's say our second pillar is agency, the autonomous operation capability mentioned earlier, and this is implemented through what's called an agentic loop or an agent framework. How does it work? You give the AI system a high-level objective, like let's say, conduct reconnaissance on this target network and identify the most valuable data repositories. Okay, the AI says, all right, breaks that objective down into subtasks. Let's see. To do that, I need to do these things. It might decide it needs to first enumerate the network to find live hosts, then identify what services are running on those hosts, then determine which services might provide access to databases or file servers, then prioritize those targets based on likelihood of containing valuable data. But here's the key difference from traditional AI. The system doesn't just plan these steps and tell you about them. As you probably figured out by now, it's actually executing each step. It's saying, okay, let me see, what do I need to do? And it does it. It evaluates the results, dynamically adjusts its approach based on what it discovers. If one reconnaissance technique gets blocked by a firewall, it might autonomously switch to a different methodology. If it discovers an unexpected service running on a non-standard port, it can pivot to investigate that without waiting for human guidance. This is the loop aspect. The AI continuously cycles through observation, decision-making, and action. And critically, it can run this loop hundreds or thousands of times without requiring human intervention at each step. All right, so then we have the third pillar of tools. And we're talking about tool access. This is what transforms agentic AI from an interesting technology into something with real-world impact in cybersecurity. So MCP, Model Context Protocol. Through something called the Model Context Protocol, or MCP, AI systems can be given access to external tools and APIs. In a security context, this means the AI can actually execute commands, run scripts, interact with databases, make network connections, and manipulate files, for example. So it's got access to use the tools. Kind of like you think about what they used to say about the difference between mankind or humankind and animals, that it was humans' use of tools. So now we've got technology directly using tools. Something to think about, I guess. Is it a threat? Of course it is. Of course it is. Can you stop it? Can I stop it? No. But we have to train on what's going on and what we need to do to protect our organizations and ourselves, I suppose, right? Okay, so let's think a little bit more about what this looks like. An AI system with MCP, that was Model Context Protocol, access, might be connected to tools like network scanners, like Nmap for host discovery and port scanning, web application testing frameworks like SQL Map, SQL Map for database exploitation, password cracking tools like Hashcat or John the Ripper. Let me mention, John the Ripper is so old. It's not a new technology. It's been around for a very long time. I played with it back in 2013. That's 12 years ago, and it wasn't new then. I don't think it was new. Anyway, packet analyzers like Wireshark, another example, for traffic inspection, and scripting interpreters that let it write and execute custom code in Python, Bash, or PowerShell. Now, I don't know if at this point, if I've talked to you about Wireshark too much previously, or if there's a lesson on it before this, because I might insert one if I don't already have one in there. So I'll probably insert one later. I don't think it's there yet, and it might have already come by this point. I'm not sure, but I just want to mention that you can safely download Wireshark on your computer. And, the ideal thing is to always do everything in a virtual machine anyway, but making sure, of course, that you are only going direct from the source and doing everything carefully. But it's a really good thing to see and experience and use and learn how to use. It's one of those things you'll hear constantly. I've probably said that a million times, sorry. So scripting interpreters that let the AI write and execute custom code in Python, Bash, or PowerShell is the other tool I was going to mention. The AI doesn't just have theoretical knowledge about these tools. It can actually invoke them. pass them to appropriate parameters, capture their output, interpret that output, and decide what to do next based on the results. Oh yeah, and one more thing, Wireshark is not new either. I think I only actually tested it out for the first time back in 2017 or 2016, but I'm pretty sure it wasn't new then either. I'm sure that if I have a lesson on it specifically somewhere in the course at some point, I'll end up telling you exactly when it was released, these things. But at this point, so the important thing here, again, we want to mention that an AI that can only talk about security concepts is fundamentally different than an AI that can actually perform security operations, obviously. It's like your toaster. Having your toaster sitting there is fundamentally different than having a robot that goes and opens the bread, and pulls out a couple pieces of toast, puts it in the toaster, butters it for you, and delivers it to you. Not the same thing at all. Now, when you combine these three capabilities, we've got the access to tools, the agency, and the intelligence. Sophisticated intelligence, autonomous agency, and direct tool access. Here, you get something that represents that genuine paradigm shift in cybersecurity. And that's for both the defense and offense, right? It's never just only going to be, here's your super powerful tool for defending yourself, and cybersecurity adversaries or, bad actors, they're not going to be able to figure it out. And that's not realistic. Historically, conducting a sophisticated cyber attack requires significant human expertise and time investment. Now, again, we've known that there's a ton of script kiddies out there purchasing tools from other people or having other people do it, but things are changing dramatically to make it even 1,000 times easier for somebody who knows a lot less to be able to do it. But also that time investment part is key, because just think of how much you could do in life if everything you did just took a fraction of the time. Though for them, they can do a lot more as well. A penetration tester or threat actor would need to manually perform reconnaissance, analyze the results, identify promising attack vectors, craft exploits, handle errors and unexpected conditions, and maintain operational security throughout the process. And it took days, hours, weeks, focused human effort. Now, with Agentic AI, many of these tasks can be automated and parallelized, happening at the same time. The AI can run multiple reconnaissance threads simultaneously. Now, I don't think they weren't doing that already before, but they were doing it in different ways. And now they can do it a lot easier with a lot less work. But you don't think that serious hackers only have one computer that can only do one thing at a time. But yeah, now it's a much bigger scale. So it could test dozens of potential vulnerabilities in the same amount of time it would have taken a human to test one, depending on what they were using. It can maintain persistence across multiple compromised systems without the cognitive load that would overwhelm a human operator. And perhaps the most significantly, it can do this 24/7 without fatigue at the speed measured in requests per second rather than actions per hour. Well, the people have been using bots forever to do things 24/7, but this is still just much more significant. But a lot of times your typical people, and they're hearing about this in the news, they don't really understand what has been going on already. So this seems like something that there was no way to do at all is suddenly possible. The fear mongering is huge around this right now. But yeah, it's being made a lot easier, for sure, and a lot easier to do at scale. So we've got Jacob Klein, Anthropic's head of threat intelligence, put it this way when discussing the attack that we're going to examine in detail. He said the attackers conducted their attacks literally with the click of a button, and then with minimal human interaction. He added the human was only involved in a few critical choke points, saying, yes, continue, don't continue, thank you for this information. Oh, that doesn't look right. Claude, are you sure? This is the new reality we're dealing with. So what he said right there, attacks that would have required a team of skilled operators working around the clock can now be largely automated. Or attacks that would have required a team of skilled operators who were good at automating things. But now it's just a lot easier with humans only stepping in for strategic decisions. Well, that's what makes AI great, and the attackers are using it that way too. Like I said, everything about agentic AI in the offensive context applies equally to defense. Security operations centers can use agentic AI to automatically investigate alerts, correlate events across multiple systems, perform automated threat hunting, and respond to incidents at machine speed. Vulnerability management teams can use it to automatically discover, access, and prioritize security weaknesses across large environments. Incident response teams can use it to automate the tedious as parts of digital forensics. The dual-use nature of this technology is critical to understand. The same capabilities that make AI dangerous in the hand of attackers make it powerful in the hands of defenders. And we'll dive into the dual-use characteristics later in the course at some point. I'll probably have this lesson and the next lesson released first before I'm able to get that final dual use lesson released, but I'm going to wait to release this lesson until I at least get the second lesson specific to this big news article released. So hopefully I can get that done quickly for you guys. So we've got the inflection point. Anthropic's research team, in their analyses of the September 2025 attack, and just so you know, today is November 16th, 2025. So that's how current this lesson is for whatever date and time you're watching it. Anthropic's research team stated that they had recently argued that an inflection point had been reached in cybersecurity, a point at which AI models had become genuinely useful for cybersecurity operations, both for good and for ill. So that's the quote. And this wasn't speculation or theoretical analyses. They had observed this inflection point in action. They had watched as sophisticated threat actors took their AI system designed to help developers write better code and weaponized it into an autonomous cyber espionage platform. They were able to see things that were happening in the platform. And we'll examine that more in detail in that next lesson I mentioned, because it's the first documented case of a large-scale cyber attack executed without substantial human intervention. We're going to walk through exactly how the attackers did it, what techniques they used to bypass AI safety controls, and what the implications are for how we think about the threat landscape going forward. So for this lesson, we're about to close out. The key takeaway: Agentic AI represents a fundamental change in what's possible in cybersecurity. It's not just a faster way to do things we're already doing, it's a qualitatively different capability that changes the economics, the scale, and the speed of both offensive and defensive operations.